All right, this is lesson 7.4, exponential versus linear. Our objective is that you'll be able to identify if a function is exponential or linear from tables and graphs. You should also be able to compare the two functions to each other. All right, so the big takeaway from 7.4, the one thing I want you to remember is I'm going to show you a strategy to determine if a function is linear or exponential. We've been playing What's the Function in class, and remember that game has us, I think of a function, I don't tell you what it is, and you guess inputs, and I'll give you outputs. So let's say you guess 2, and I tell you the output's 5. I'm taking these right from here, by the way. So maybe you guess 4, and I'll tell you the output is 10, and maybe you guess 6 next, and I'll tell you, okay, well, if I put in 6 into this function, the output would be 15. If you did something like that, then you are using the strategy that I've been recommending you do for a while now, picking inputs that are evenly spaced. Notice 2, 4, 6, you're just counting by 2s. You don't have to count by 2s. You could count by 1s, you could count by 5s, you could count by 10s, doesn't matter. But once you choose your inputs and space them out, maybe your first 2, then you need to keep going by that same amount every time. Like these are 2 apart. That's all this note is saying here. And that's the first thing you should check when you're given a table is, do we have evenly spaced inputs? Yes, we do. Again, in this table here, do we have evenly spaced inputs? Yes, we do. All right. If we have that evenly spaced input property on our table, then it's going to make it a lot easier for us to find patterns. And one pattern you might want to look for is, are you adding the same thing every time? Linear functions are additive. That's what it should say in the blank. All I mean by that is that you should be adding or subtracting to get from one output to the next. And notice, we definitely are doing that in this table. We're adding 5. 5 plus 5 is 10, and then 10 plus 5 is 15. Another way to phrase this is that as long as you have evenly spaced inputs, this table, the outputs are going to form what we call an arithmetic sequence if it's linear, right? In other words, our outputs have a common difference. If the function's linear and our inputs are evenly spaced. All right. The next blank says exponential functions are multiplicative. And again, all I mean by that is that if the function's exponential and you have your evenly spaced inputs, then these outputs are going to form a geometric sequence. And sure enough, I'm not adding 5 both times, I'm actually multiplying by 2 to get from 5 to 10 and then again from 10 to 20. So these outputs do form a geometric sequence. It has a common ratio. In this case, R is 2. We're multiplying by 2 each time to get from one output to the next. All right, we are going to have some word problems, so I have a table here just to highlight some key terms that you might see. If you see words like each or increases by, you're dealing with something that's linear. But if you see words like percent, or maybe it increases by 10% each month, or whatever it is, or maybe something's tripling every year, or doubling, or remember, triple means times 3, double means times 2. You probably know that. But if it might say increases by a factor of 5 or something, by a factor of 4 or 10, whatever it is, that means you're multiplying by whatever that number is, whatever that factor is. Okay, so let's get right into it. We have a word problem. Kim and Cindy are starting a business tutoring students in math. At the end of the first month, they make $400, and the cumulative total of money they earn increases by $200 each month. So increases by $200 each month. You should be thinking, okay, this is linear. We're adding something to get from one term to the next. We have another business here. Joe and Kyle are starting a business tutoring students in science. At the end of the first month, they make $100, and the cumulative total of money they earn doubles each month. So we should be thinking this is exponential. We're going to be multiplying by 2 to get from one term to the next. I probably should put plus 200 here. And then it asks us, what's the first month where it should say science earns more than math? Let's make a table. There's different ways to do it. I recommend making a table. So we'll have a column for the month. We'll make a column for how much money the math business has made, and then a column for how much the science business has earned. All right, so in month 1, math made 400 and science made 100, right? So we can fill in $400 for math, $100 for science. In the second month, it tells us that we're increasing by $200 every month. So we're going to need to add 200 to get how much the math business has made in the second month. And so 400 plus 200 is 600. However, the science business, even though they started out making less money, they're going to double every month. So we're going to times 2. 100 times 2 is 200. All right, and so far, math made more than science in the first month. It's still earning more than science in the second month. So let's keep going. In month 3, we're going to need to add 200 again. So 600 plus 200 is $800. And then same thing for science. If we multiply by 2, 200 times 2 is 400. And math is still earning more, so let's do it again. 800 plus 200, it's going to be 1,000. And 400 times 2 is 800. Ooh, we're getting closer. Maybe we just need one more month. So in month 5, math is going to earn $1,000 plus 200 more. That'll be $1,200. And then in month 5, science is going to earn double 800. 800 times 2 is 1,600. And sure enough, science is earning more than math that month. 1,600 is more than 1,200. Let's just write our answer out in words. So we could say after month 5, or after 5 months, the science business earns more than the math business. There we go. Hopefully you see that pattern where this is linear, we're adding 200 every time, but this is exponential. And as we do more of these, you'll notice that exponential functions will eventually, it might take a long time, might not, will eventually grow faster than linear. All right, let's do one more, and then we'll be done. We have an apple critters farm that picks apples. They pick 150 apples on their first day of harvest season, and they pick an additional 60 apples each day. We're adding 60 each day. This is, well, you tell me. Is this going to be linear or exponential? Pause the video, answer the question, then come back and check your work. All right, we're adding 60 apples each day. This is linear. Then we have Peachy Farms. They pick 50 peaches on the first day, but then they pick, oh, I'm sorry, there's a typo here. This should say 50. Can you change that 5% to a 50%? That's going to save us a lot of work. It would still catch up eventually with 5% more each day, but for the sake of time, let's make that a 50. Because it's saying 50% more, we should be thinking this is exponential. Now, the percentages make it a little bit more tricky. It's not just doubling, because then we'd be multiplying by 2, right? In the last video, we talked about exponential decay, where if it's like decreasing by 5%, then it'd be like 100% minus 5, so you'd be multiplying by 0.95 or 95%. Here it's growing, so we want to think of this as our common ratio is going to be 1, which represents 100%, plus 50% more. But 50% as a decimal is 0.5. You could write it as 0.50 if you want. So our common ratio, the thing we're multiplying by, is going to be 1.5. Now that we know that, oh, and I forgot to say, this is plus 60 each time. Now we can make a table. So let's make a table with which day is it? How many days since the first day of harvest season? We can look at how many apples were picked by Apple Critters Farm and how many peaches were picked by Peachy Farms. On day 1, well, it tells us that already. They picked 150 apples and only 50 peaches. On day 2, let's see. We're picking an additional 60 apples a day. So we're going to add 60 and we'll get 210. But Peachy Farms, it's picking this 50% more. That means our R is 1.5. We're going to multiply by 1.5. 50 times 1.5 is going to be 75. You're welcome to use a calculator if you'd like. As we keep going, we'll probably get more decimals. So let's keep going, because Peachy Farm still picks that the number of peaches is still less than the number of apples. So I'm just going to fill in a few days here. All right. So we need to add 60 every day for the number of apples. And we need to multiply by 1.5 every day to get the number of peaches. All right, so 210 plus 60 more means that on day 3, they will have 270 apples. If we add 60 more to that, we'll get 330. If we add 60 more to that, we'll get 390 and 450. Let's see if that's enough. Let's fill in the number of peaches. All right, so if we start with 75 peaches in day 2, multiply that by 1.5 and you should get 112.5. If you multiply that by 1.5, you should get 168.75. Multiply by 1.5 again, you should get 253.125. And multiply by 1.5 again, or 1.5. We should get 379.6875, I think. Now, we don't really have to write all these decimals. It makes no sense, right? Really, you can't pick half a peach. You can't pick 0.75 of a peach or 0.125 of a peach. And this is where we have to use our own judgment. In this context, we probably want to approximate by not rounding. Rounding is where, okay, if I were to round this 112.5, because it ends in a 5, we'd call it 113. But really, we haven't picked 113 peaches yet, so we would probably just, the fancy word for this is called truncating. We're just cutting off the stuff after the decimal. So it's just 112 peaches. Same thing here. If we were rounding, we'd call it 169 peaches. We're just going to cut off the decimal, 168. Let's truncate the rest of these. So 253, 379. But notice the number of peaches is still less than the number of apples. Let's do another day and see what happens. On day 7, if I add 60 more peaches, that means we'll have 510 apples. And then for the peaches, if we multiply by 1.5 again, 379 times 1.5, we'll get about 569.5 something. Again, just truncate that. 569 peaches. That's bigger than 510. So we're just gonna answer that more peaches will be picked on day 7. And that's it. As always, ask a question at the end of the video or make up your own, and I will see you all in the next one.